Hi, my name's Tim Gilbert. I'm your BUS320 instructor, and I want to talk to you about Chapter 7, Section 2, Estimating a Population Proportion. What I'll do on this video is simply go through a calculation. There's a number of other slides that you should look at up on Moodle that are in the full PowerPoint, but I want to go through the calculation just to give you a heads up and a little insight into what the homework looks like. So we want to construct a procedure for, or have a procedure for constructing a confidence interval for a proportion. We aren't sure what the true proportion is, and that's why we put a confidence interval around it. You'll often see proportions given in around election time, that a certain proportion of people are for or against a candidate, and they'll put an error estimate around it, or a confidence interval estimate. And they'll say an error, maybe a proportion of 0.47 or 47% plus or minus 3%. Well, this is where that error estimate comes from. So this will be kind of fun to learn how it's calculated. The error estimate is simply the square root of, or the error is the square root of the proportion estimate that you have, its complement Q, it's P hat and Q hat, that's called, over N. So we calculate a margin of error, and then we add and subtract that from our estimate. So P hat is called that in that it's not the true proportion, but it's our best estimate of the proportion. And we subtract an error estimate and we add an error estimate to it. So we want to find an error estimate or a confidence interval around 829 adult Minnesotans, who 51% of them are opposed to the use of photocop. So we first check our assumptions and say make sure that N times P hat is greater than 5, and here it's 422.79, and N times Q hat is 406.21. So both of those are much greater than 5, and they meet our requirement so that we can do this calculation. And we use P hat 0.51, which was given to us, and the complement of P hat 0.49. We use that in our standard deviation calculation. You'll recognize this from some previous work. It's the square root of P hat 0.51, Q hat 0.49 over N, which is 829. So that gives us a standard deviation, and this is our old friend from table A-2. Remember when we were looking at it and we were looking for 95% confidence interval, or 95% spread of data, 47.5% in each direction? Well, you'd have to travel out to a z-score of 1.96. So that it's called Z alpha divided by 2, alpha being 0.05. That's Z alpha divided by 2 right here, and that equals 1.96. And what that simply means is 0.05 for alpha divided by 2. It leaves 2.5% in each tail. So 1.96 times the standard deviation estimate gives us 0.03403. Well, that's the error estimate. But to see what our final numbers are going to be, we need to take P hat 0.51, which was given to us, subtract the error estimate, and that gives us 0.476. Then P hat plus the error estimate, 0.544, 0.544. What that tells us, we're 95% confident that the true proportion of Minnesotans opposed to photocop are between 47.6% and 54.4%. That contains the true percentage. However, a majority requires a percentage greater than 50%, so we really can't say, just to talk about that for a second, we really can't say a majority is opposed, even though it goes up to 54.4, that bottom part of the interval or boundary, 47.6, is less than 50%. So the true proportion could actually be less than 50%. In order for us to make the statement that the majority really are for or opposed to photocop, we would need a confidence interval that would range from 0.51, say, up to 0.58, and that would mean that the bottom boundary is above 50%. So as long as it includes 50%, we really can't say the majority is opposed to photocop. That's simply proportion estimates and confidence intervals. It's a nice step up into inferential statistics and a handy tool to have. So take care and enjoy your statistics.